Aya?
Yes.
Sir, perfectly fine
Uh,
hai. Perfectly fine. Perfectly fine.
Fine. All right.
Perfectly fine.
Good morning, everybody.
Good morning, sir.
Good
Good
morning,
Good
sir.
morning,
morning,
sir.
sir.
Good
Good
morning,
morning,
sir.
sir.
Good
Good
morning,
morning,
sir.
sir.
Thanks, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Uh,
Good morning, sir.
A very good morning, sir.
Very good morning to everybody. I hope everybody is fine. And in this session, we are going to talk about the supervisorship or guide preparation. Who can become a research guide? There are a few lines which have been written here just to introduce the subject. That a PhD degree is not essential to become a research supervisor or research guide. But it is essential that you should have at least research experience to do something in different fields, either science or arts, music or languages. So in one discipline, one has to be well versed with the subject and should have experience of doing the work in a given area. A PhD program has a written project that you have to be limited to that area, but you have to learn many things which are attached and which are related to it. Like, for example, if you have to cook rice, then you have to have utensils, you have to have spices, oil, and burner. Likewise, if you are going to cook meat, you have the same thing common, but there are different ingredients. So that depends on the discipline and the type of the work, whether it is a laboratory work, whether it is a field work. So a research guide should be well versed in a given area of the discipline and the related areas where the help is needed. So a person, it's better that to have a PhD degree, but if not, then should have at least some experience of doing research on a given area. There are some prerequisites to become a research guide. That is, according to the rules, that one should have a PhD degree, should have enough experience while doing work in a laboratory or in the field. If you have a PhD degree, it means you have spent at least 3 to 5 years in doing research, and you know that how to expand your area and how to find out the results in a given discipline. I may have published at least 2 papers. This is prerequisite of UGC and some of the laboratories that the colleges impose on a teacher, that you have to have experience and publication and a degree. Must also hold a permanent position in the institute or in any teaching organization. If you are on contract basis for 1 or 2 years, I know the difficulties and the restrictions that you do not have a laboratory facility, you do not have a proper sitting place, and you are loaded with a number of classes where you do not spare time to do research. So it is therefore essential that you should have time and should have a research laboratory to work on, or you shall have at least facilities provided by the college or the institute. These are some of the things that are basic and essential for a teacher to have all these facilities available, or which should be provided by the institute or the college in which a teacher is working. And should have some written permission, either if it is an affiliated college, then you should have written permission from the university that you can become a research guide and you can carry out research, and your student can be registered in the college or the university for a PhD degree. That is some of the things which are related to your institute or your college. We have to see the rules and some of the rules which are laid down by the college. Teaching and research, it's a continuous process, as you all know, that if we do not teach a subject, then we forget it. And to scratch it again and again, you have to learn something which is being added from time to time. Like in a discipline, or if you go to the atomic theory, initially, John Dalton told that the atom cannot be divided into various fragments. In 18th century. But at that time, there were no machines, there were no equipments where it could be verified. But at that time, it was known that atom cannot be divided because we did not have cyclotron. Therefore, it was accepted that atom is the smallest particle of independent existence. But further researches by Moseley, Rutherford, and our periodic table that suggested that atom can be divided into various fragments, and we all know it very well. So we have to learn things step by step, and whatever the developments are coming in that area or in that field, we have to add it to our knowledge. There are salient points to become a research guide or to become a research supervisor. That is to be seen as a point of instruction. That is knowledge of designing a PhD program. PhD program is to be designed means you have to make a project of doing your work in different phases. So if you plan that you can complete your work in 3 to 4 years or 3 to 5 years, then you have to divide the program in different phases. 1 year, 2 years, 3 years, and the 4th and 5th year for collecting data and writing the thesis. So you have to make a project of your work in a given area. When you prepare it, you should also look for a plan where it can be executed, which means you should have a laboratory to work. If you are doing in sciences, if you are doing in languages or in any other area like music or games and sports, then you have to go to the field. So a title is to be given to your project. Like, for example, if you are studying in physics, then you should have to, or you should write a project and give it at a light. For example, if you are doing something in spectroscopy, then write which is spectroscopy, either infrared, laser, or NMR, or UV visible. That depends on your expertise. So write a suitable title of your work and whatever you need for that work in the project. Like, if you have prepared something like in physics or in chemistry, you are trying generally to prepare a compound. Then you have to write the name of the compound and those things which are needed for it. These things should be elaborated and its availability should be looked at. The third point is must be able to write a research paper. You learn it stepwise. First of all, once you start working in the laboratory, you collect the glasswares, you have to have distilled water, solvents, and those chemicals which you need. You collect everything together, and then you keep writing whatever you do in the lab. If you are preparing something, then you should write the recipe of it. And then you go to prepare some compound, then you should write the ingredients and quantity and how do you find what are the changes. These instructions are to be followed very strictly. And every time when you see it after 24 hours or after 10 hours, the day after you have completed that work. So everything should be written. And once you have written everything experimental or from the preparation or discussion viewpoint, then you write everything in words on a paper in different sections like materials, experimental portion, instrumental portion, and then discussion. So then you will be able to write a research paper in the same context, in the same sequence. Should be able to write a thesis. If you are writing a research paper, you would be able to write a thesis also, because thesis is comprehensive written work of a research project. Once you complete your project, you can write them in detail. But here you have to write the introduction to introduce the subject to the reader, that whatever has been done earlier and whatever you have added to it. So can it be used as a text for people who are joining after you to do research in the same field? So once you write the thesis, it should become a sacred document worth reading, worth studying, and also it should add some knowledge that you have done. And the final result is to be done. Some recommendations are to be made. So once you write the complete thesis, you should add the references and further related work. The next point is, should be able to operate instruments to be used in your research. Like, for example, if you are working, which is very common today, the nanotechnology or nanochemistry, or in physics or in biology, then you should, like, for example, spectroscopy, you should be able to work on this instrument. Today, if you do not have the instrument, you can take the help of other people from other departments or other laboratories. Like if you do not have an instrument, you can do it from any other laboratory who are using it commercially. Then you make the payment and get the results. But you should be able to interpret the results. Like, for example, if you take the ultraviolet spectrum of any liquid or any solvent dissolved in a solvent, then you should know that the UV spectrum can be varied or can be recorded from 200 to 400, generally given in the instrument. So you should not exceed 400. If you go beyond 400, that will be visible region. So if you are doing the ultraviolet spectroscopy, then you should restrict yourself from 200 to 400 nanometers. And there you get the result. Therefore, using the instrument is the operation. And getting the result and interpretation is your work, what you needed. If you get a peak at a given point, like 230 or 250 nanometers, then you have to interpret what material you started with and where it is expected to give you peak. And if it is a new compound, then you are the first person on pioneering it to get the peak. And that peak will correspond to the compound and the chromophore present in it. The next one is to interpret the data obtained from the experiment. If you are doing this, then you should be able to translate it into words. That what does it mean? If I say there is a peak at 230 wave numbers, then 230 wave number should correspond to any given compound. You should then say this is the structure of the compound, and we are getting a peak at this, which is a signature peak of this compound. Therefore, you have obtained a peak that could correspond to your compound or to that item where it absorbs. So absorption, the optical density, and the peak at which it appears will be a point where you can identify the molecule. Therefore, you should be able to interpret the result in your terms, depending on the type of the compound that you have taken, the solvent you have taken. should have knowledge of computer. Today, I don't understand that the people need any help for computer because the normal calculations can be done usually in a computer lab or using your own laptop. The computer knowledge is essential for everybody because it is something that everybody needs. Either you are in science or in arts, you have to collect the data, and from that you have to write the result in words. For clarification, you have graph, you have histograms and figures. Either it is planned or it is a selection of data. So it has to be produced properly, and if you are using computer, that will save your time. This is basic thing that one should have knowledge of the computer operation and using them in your work. There is always a question that how many students one research guide can guide. For guidance, there are certain norms which have been framed by UGC also, and mostly by the colleges and universities, that an assistant professor should have 1 to 3, associate 3 to 5, and professor should have 5 to 7. It is not a number, but it actually depends on the time that you have spared. An assistant professor, for example, if he has 15 classes per week, which means that he should have at least 2 classes per day. And after doing 2 complete classes, 1 in the morning and 1 in the afternoon, if you can spare time, if you have enough students, and if you have enough laboratory space, then you can use your time. So depending on your time, you can register 1 to 3 students. If you don't have much time, you can start only with 1 student. Similarly, a professor has lowest teaching load, maybe about 5 to 8, maybe in some of the colleges it may be 5 to 10. And if he has enough time, he can have enough number of the students for guiding his PhD thesis. The other thing is that if you have some research students who has completed his research and getting a fellowship, he can help you out. So a research guide can seek the help of senior students also, and that will be an added help to the newcomers who just start the work. If you are trying to expand your work, then you should expand the knowledge and also try to disseminate that knowledge among the students so they could be able to pick up the things quickly and get to the point and write the work. So it's a usual schedule that when you spare time, if you are free, the college allows you to do the research. Some of the college don't allow you to do research. They will get you engaged in some other work that is related to the office. So you don't find time to carry out the investigation in the laboratory or even that depends on your time, on your skill and your association with the students. Therefore, the quota does not mean that you should have a fixed number and you should always guide them. It is the number of the students whom you can guide properly, depending on the facility and the availability of the space in an institute. As I said in the beginning, you should have some experience of doing research, should have published, should have presented papers in conferences, symposia, seminars, or written a book, written a paper in a journal, or if you have guided some postgraduate research project in your department, spanning over 3 to 4 months because the MSc schools do not have much time. They are restricted to the number of semesters. So third and fourth semester, if you are guiding some project as a part of their curriculum, you should be able to write a paper also, because that is an added experience to your credit. Here, a PG project in most of the universities, especially in Ali Muslim University, in the last 2 semesters, there are seminar lectures assigned to the students, where the seminar lecture is always related to the research or some research work that has been published by some people or your own research work. That lecture gives you an insight into the work, how to do that work and what results have been obtained. If they are contradictory, they should be repeated in a lab or in the field. And therefore, that is also an experience. That is a short time experience of about 3 to 4 months for PhD program and also for a postgraduate project. That experience gives you small projects, and those small projects are all not always the same. They are of different types, one related to one part, one related to another part, as your syllabus has been divided into various chapters. Similarly, the project has also been divided in different sections. So one is doing in solution, one is doing in solid, one is doing instrument, one is doing something in theory. These are the experiences of the people who are doing their work. So it will be helpful for a research guide to do work in a given discipline to an extent of 3 or 4 months, if it is a project designed for that postgraduate work. Because that has to be completed within that given time. Now, next is, if a teacher is applying to become a research guide, then he should be trained in a given technique, at least in one instrument. If somebody is specializing in sports, then not all the sports are related to each other, but special techniques are available. Like, for example, in hockey and football, both of them are played in the same field, but here the number and the objects that are being used, like hockey stick and ball. In football, you have to have only one ball, and there are different exercises which are related to that sport. Therefore, one has to specialize in one area, one game, one project, and one subject. Like here, one has to become a research guide. Then you should qualify in your area. If you are doing, for example, in physics, there is thermochemistry, there is nuclear chemistry, and there is heat, electricity, magnetism. There are different areas. Which area you select or which area you have specialized in. And you would therefore work in the same area, but you need the help of other people also, because the related areas are also connected to it, where you need the help of your colleagues. Working with the techniques, or sometimes you develop your own technique. Like in analytical chemistry, I know that electrophoresis was developed long back in sometime 1930. And electrophoresis is a technique where you can identify the ions through electric supply with a change in potential in solution. This technique is useful in identifying the ions. If you have a collection of ions, 3 or 4, we do not know which ions are there. You can use the electrophoresis technique to identify the ions. And one has to be specialized in that area so that you could help other people also in doing the analysis. The next is additional qualifications are involvement of discussions, seminars, and technical developments, as we always have questions on how and why. These two questions are always placed before the teacher and the students. If you are able to answer these questions, then you will always look into it and find out the best possible explanation for every question. Like, if I say, what are the transition metals? Then you would have a simple question. Transition means something in between or something intermediate, which has a property of non-transition and transition elements. So intermediate property means you have a transition here, which can have a property of both. Likewise, if I say metalloid, metalloid is something between a metal and a non-metal. And you can identify which are metals and which are non-metals, and which have intermediate properties. Therefore, we can classify them as metal, non-metal, and metalloids. Likewise, we can have transition metal, non-transition metal, and those which are gases. Here, these techniques and theoretical consideration will be helpful for a teacher to become a research guide, and also you can expand your knowledge in other areas. Then who can apply to become a research guide? It is the same thing that I gave you earlier. The last point should be aware of plagiarism. The plagiarism is one of the things that we understand, that if we are copying something from a written work of any other researcher and using it without any reference, it's a plagiarism. But if we refer the work, just quoting it, it is not a plagiarism. In a written paper, the plagiarism has been allowed to a certain extent. Somewhere it is 20%, somewhere it is 30%, but above that, the plagiarism is not allowed. And it will be said that somebody has copied it from one paper and referred it to as his own work. So we cannot take others' work for our own credit. This plagiarism can be read as a reference. So it is always necessary that we should not copy it. We should make use of it in our work and referring it that somebody has done it and the credit goes to him. But we are using it as a reference to support our work. So one should avoid using the whole copy of the work, but should take the help as a written work. Limitation number of students to be guided by supervisor, that I have already given to you, but it is a further explanation. It all depends on the subject, time, space, work, equipment, facilities available, and depending on the college management, whether college allows you to work or the facility is not available. Like mainly in some colleges, there are some minor instruments that can be available to their use. Well, it has been found that if somebody is working in theory, it's easy, but one needs a very fine computer. That computer is not available in their college. You have to take the help of some other organization. If the facilities are available in your organization and if you have time, you can continue doing it, either theoretically or experimentally in the lab. You should have only the working place, at least some instruments, some stays, some tables, some chairs, and the instrument for a discussion. And once you discuss it, you can find it out that it is feasible under your environment, because it is always essential that you should work in an environment which is feasible, where the college allows you to stay or preview classes are over. Involvement of the department. This is another factor in the passage of being a research guide. That allocation of the student, the board of the studies in a department has to frame certain rules, and that is dependent only on the number of classes that you take every day. The board of studies will decide the number of students for you to guide for the research work. And a research interest of both the guide and the student. Sometimes there is a conflict between the student and the research guide. If I have facilities available in the laboratory for a certain work, but the says that he cannot do this work, he can do something which is not available here. So in that event, either you modify the work or you allow the student to take the help of other people from other laboratories. Teaching load of the faculty member, I told you earlier, that depends on your availability in the department, how much time you can spare. Your expertise, in which area you have expertise, and where these facilities are available. The next is the students qualified. Qualified means if you have qualified the eligibility test and getting fellowship. If the fellowship is available, you should have a contingency grant also to buy some of the chemicals or some instruments to work on, or even books and stationery. If the facility is available in the institute and things are being provided by the department, you can carry out this work there also, but the student will require some financial aid. Eligibility criteria to become a research guide according to the UGC rules. These are the same rule, but there are certain things which have been added to it. Like second point, part-time teacher. Part-time teacher or guest faculty or contractual appointments, they cannot act as a research guide. I can understand the difficulty with the contractual teachers, because I know that the university or the college does not have the space for them to sit. When they can place their register, they can teaching materials. And therefore, if this is the condition, how can he find time to do research? Everybody in the interview asks how much time you are spared for research, or for the last 2 years, how much research you have done. The poor fellow does not have a space in the laboratory, does not have time from the classes. So how can he do the research work, and how can he produce a research paper? So it is difficulty with the people who are on contractual basis. But for a permanent teacher, he should have time and is there for this. Allocation of the supervisor will be done by the department. Allocation, that number of the students, that depends always on the availability and your space. The fourth point is the interdisciplinary work. Sometimes we work in an area which overlaps with other areas. Like there is a area today which is expanding very fast. The nanotechnology, nanochemistry, nanophysics, and even in agriculture, there is an extensive use of nanotechnology. I can give you some of the examples here. Like nano means very small particle or very small size of the order of 10⁻⁹ meters, which cannot be seen by your naked eyes. It can be seen by scanning electron microscope or transmission electron spectroscopy. These are the two cameras which are being used for scanning and find out all the size of the particle that you are using it. If you are doing in agriculture and using the nanotechnology, then you do not have the scanning electron microscope, you have to take the help of other people who are using it and who have it in their institute. So for that work, or even if you are working in agriculture and taking the help of microbiology from other departments, or if you are working in biology and taking the help of the people in medicine, because your work in geology is related to human system. So one can take the help of the medical colleges and especially in microbiology. So there you need one supervisor from your parent department and a co-supervisor from any other department. Generally, such departments or such institutes do not award the PhD degree. So mainly the PhD degree will be awarded from your institute where you are working as a teacher in any recognized college or a university. The co-supervisor can be appointed from any non-teaching organization, like any science laboratory of CSI or GC, or any like ITRC, or any laboratory related to medicine or chemistry, which are non-teaching organizations. So one supervisor from a teaching institute and a co-supervisor from a teaching or non-teaching institute, where you take the help of that supervisor in operating the instrument or taking the help of instrument. So two supervisors can be appointed for that one in consultation with the department and the two supervisors. If the Board of Studies permits you to have two supervisors, so one supervisor should be from the other discipline or other department to help you out, either in instrumentation or in the subject. So these, some of the points are related to it in case you have to have two supervisors to get better results and better facilities available. It is the same that I gave you earlier, that the distribution of the students according to the qualification of the teacher. Professor can have maximum number of students, that is 8, and if the teacher is only MPhil, an assistant professor can have only 1 student. That is to be decided by the department, and it has to be taken into consideration whether you can do the research or you do not have the facility available. There are certain facilities given to the women candidate. In case of women candidate, there are certain facilities and relaxation, like a transfer is extension or change of place, change of laboratory, or even change of title of the work can at some point, if you are working in an area and you find that it cannot be done under these conditions, you can change the title. These facilities are available for both male and female candidates, but when it is nearing completion, the change is impossible because it takes a long time and one cannot wait for a long duration of time to facilitate the work. So one has to always take care of the work and also see how much time does it take, 1 year, 2 years, or more than 3 years. So this is the point where one can take the help of the college, and the lady candidate can get the maternity leave depending on the college and the facilities, but at least 3 months is given generally in every college. Selection of research problem and phases of research stages. These stages are the same irrespective of the problem. The place, institute, the environment, the subject, and also the availability of your space. These are common points which are related to your work. So the preparation of the work is essential because one has to have a prior knowledge of the subject. One should be able to work further from a given point. Like if something has been done, you can take the help of that, but you have to extend that work. That is also research. But that depends whether it is a field work or you are doing it in the lab or you are doing it theoretically. So there are points. Number 3, if you come to imagination, hypothesis, experiment, and theory, these are the things where I have to make certain points and explain. Imagination means you have to just dream it. If you don't imagine, then you cannot propose a research work. Here, imagination means I can give you an idea of how to imagine. Like people had always been looking for certain developments in different areas. I can give you one example of imagination, that if you imagine that you can fly in the sky just like a bird. This was the imagination of 2 people who thought that we can fly like bird. So they imagined it. Theoretically, they did not have any machine. They were not like birds, but they thought that if you flatter your wings, you can fly in the sky. And that was the poor fellow named Icarus. So he thought that he can fly. He jumped from his roof, fluttering both the hands like a bird, and fell on the ground and he died. That was the first imagination of flying in the sky by a person who tried unsuccessfully. Later, the other people thought that if you have to fly, you do not have wings, you have to prepare wings. Have a flying machine. Then came the 2 Wright brothers, Orville Wright and Wilbur Wright. Both of them thought that if you have to move your wings, you have to have a propeller. They made a very crude flying machine with propeller, with wings, and open. They tried it and they were successful. Then they made a bigger machine with a stronger engine. They flew few kilometers and they landed on the ground safely. After imagination, they put their imagination into work and they made a flying machine, and now we call it aircraft. Then comes the hypothesis. After imagination, you put those words into writing. You hypothesize that it can be done. Like I gave you one example in the beginning that the John Dalton said in the beginning that atom cannot be divided. It is the smallest unit of an element. That is a hypothesis. But if you put it in practice and try to break the atom, and the atom breaks, then this hypothesis has to be modified, that the atom can be broken. When it is experimentally proved, then it can be put in words that the hypothesis is this, and experiment is this, and then we put the theory. So it is a sequence of building an instrument or building a machine or making a research. You imagine it, hypothesize it, and then if it is experimentally proved, it can be put into theory. So theory is the result of your experiment. So every time the theory has to be proved. Sometimes the theory has to be proved by another theory through calculation. Many points developed by Newton were later modified. They were not rejected, but they were modified on basis of other calculations. Then comes the fourth point, experimentation and collection of data. When we do the experiment, we find some kind of different result. Like if you are going to plant a sapling in a pot in a given place at a given temperature, you have to write everything that at this temperature, in this pot, in this area, this plant grows. Sometimes you do not add any fertilizer to it. That grows very slowly. If you add fertilizer, it grows fast and it flourishes. So where you do it, you have to mention the conditions, that under which condition this experiment was done. And finally, you get the result. That result is final. But from time to time, if you make changes, you have to also change your results. Therefore, it is always necessary for a person to know the operation and to see the results. Now, the last point is interpretation of meaningful results. If you got the result, then you can theorize it or you can modify it. Like producing the theory and put it into practice and produce something useful, like in drugs, cosmetics, or medicine. In the recent 2-3 years, you had seen the spread of COVID-19. And vaccine was developed from different quarters, even from India. We should know that a vaccine is not a game that can be played within a fortress. Vaccine can be developed in 3 to 5 years. And we had hastened to produce that vaccine without any experimentation. That many people died. And many people have long effect. Those effects may not be useful, they may be harmful and lasting effects. So these things are to be produced after complete experimentation, only then it can be marketed. So interpretation of the result will come only after you have studied it theoretically. Like one drug I can give you here, drug or cosmetic. Zinc oxide is used in sunscreen lotion to save your skin from patches and from deteriorating in the sun. How it works? The zinc oxide in the cream absorbs the ultraviolet rays and protects your skin from damage by penetrating the ultraviolet rays into the skin. So the major function of the zinc oxide is to absorb the sunlight, or especially ultraviolet light. So use of zinc oxide in sunscreen lotion has been done over years. And finally, when it was found that it is not harmful to the skin, it can be therefore used. And every company using the sunscreen lotion in different types of the creams are showing that it is useful, not harmful to the skin, if it is applied on your skin which is exposed to sunlight. But this is a long experiment that has been done. So once it is done, it is proved, we can go further with the use of it. Therefore, modification in the theory and interpretation of the meaningful result is to be done with complete research. Now comes the presentation of the data. There are some people say it is significant or insignificant. Data is significant or insignificant should be taken into account that not only on the basis of the analysis, but it should be theoretically seen that the data is significant, but it is not useful, because sometimes if you do the experiment on plants and find the data that it is useful, you have done the experiment in a pot, not in the field. And once you take this data and apply it in the field, the result will be entirely different. Therefore, once you have done the experiment, you have got the significant data, you should use it on a large scale. And on the large scale, if it is verified, only then it can be used industrially. Presentation of the data, you can use either a table or a graph. Both of them give you higher and lower results. The graphical presentation is easy to see visually, and in the tabular form, you have to look for the highest value in the same serial order. So you can present it either in this way or that way. Concept and controversy in research. Here I gave you the same thing in the previous slide: the hypothesis, observation, experimentation, and the research. Here, one line you can see, the research is defined as the systematic investigation to know the facts. This is given by C.A. Moser, who said that science is a study of some project or some work in a systematic way, in an organized way. And the data is to be placed in accordance with the system. If you are doing it in mathematics, then you have to develop the sequence in the same order. And finally, one has to show that the result was obtained, which can be useful in the development of the chain. The second point here, you can see research is not the analysis of data only, but it is the source where you have obtained. Because one thing grown in one area cannot be grown in other areas, like saffron. Saffron can be grown in Kashmir and in areas where the temperature is very low, like Netherlands, Spain, or even in UK. But everybody is not growing saffron, because for that you have temperature and composition of the soil, which is essential. You cannot grow it here in North India, but you can grow it perhaps in Himachal Pradesh, because the temperature is very low. People have tried it and they are growing it. So that is a systematic way of presentation of your data and the given field, whether you are working in physical sciences or in biological sciences. Research can produce some good results. What we can do, the research has been divided into various sections. One is the innovative research. Innovative means you have to invent something that did not exist, like the invention of telephones that did not exist. But discovery is something that was not known that existed. Right? If we find the dinosaur was very heavy animal that existed, but we did not see the animal. Now from the fossil we know that there was a huge animal, and that giant animal existed millions of years ago. It is a discovery. Then extending old research. If we have done some research and we are going further, that is our extension of the research. One word, further progressed. We have to have most available books on research methodology, the way we can collect the information, we can collect the data, and the experimental results. And if such common information are published from the books, that is a research, but that research is not original research, because we are writing a story based on the facts given earlier. So that is an information useful that has been collected. But innovative research is one where we find something new or add something new, and that is a knowledge which can be added in your research paper or in your thesis. Before working on a project, we should look into the final points. The first point here is the French word raison d'être, the reason to do. Before we start the work, we should know why we are doing this work. This is a basic question that everybody thinks of. Why we are doing it, which means we have to see that we are not repeating something which has already been done, which has already been reported in newspaper bulletins or in research journal. Why one should take up a research project? If you are doing a PhD work, then you should be able to handle that work and should have prior knowledge. Next one is where the work is to be done. Whether you have to do it in the laboratory, you have to do it in the agriculture field, or you have to sit in a computer lab making only calculations and collecting the data. The next one, the place and facility. Where you are working. Either you are working in a well-organized laboratory or you are working in a teaching institution. In an organized laboratory, you have the facility of instrumentation, but you have not access to the practical work that you also need. So instrumentation is essential, but you also need the theoretical consideration. So instrument is available, you can make use of it. When you write it, you need some books and some also old work or thesis, where from you can introduce the subject. Then the last point is here, does this research add something to the existing knowledge in your area? One has always to do research only to add knowledge. We gather the knowledge, we extend the knowledge by doing it some new work. And if it is extended and can be added to the subject concerned, then it will be useful. You have done something that can be added to the knowledge of the common people in that area, be it sports, be it agriculture, or be it medicine. These all considerations are to be taken. Then we have type of the research. One is completely academic research, where we do either practical or theoretical. Both of them can be used. The next is applied research. Applied research is generally done by the engineering, medicine, and agricultural or chemical sciences. But an academic research is based on mainly theory and experimentation, where applied research is based on producing something of industrial use, like making candles, making better candles, making better system where we can produce light, better substances which are cheaper and can be expanded, like production of cereals and increasing the production of vegetables or fruits. That is an applied research, which can be done by agriculture, botany, zoology, and medicine. Then the other one is field research. Field research is always done outside the laboratory. In geography, you cannot do everything in the laboratory. You have to go to the field, you have to make measurements, you have to take the crops, which crop has been grown, which crop can be grown in the next season. And likewise, in geology also, you cannot do everything in the laboratory. You have to go to the field, you have to collect the samples from the rocks, certain areas, and analyze them in the laboratory. So these are the types of the research depending on your subject and area and their analysis in the lab. Finally, writing a research paper. You do not write the abstract in the beginning. Once you have collected the data, you have everything in your notebook, then you start writing the introduction. Whatever has been reported earlier, and you refer to your work. In the end of the introduction, one has to write why you took up this work and what are you going to present in this work. Then material and method. Material and method, where you have to write the type of the chemicals, type of the books, type of the instruments used, and the methodology. And finally, results and discussion. Through your results, you have to discuss it, how it has improved it from the previous work and what you have added to it. And in the conclusion, you have to write that you have got this result. It can be expanded further, and the other technologies can help it improving in the same given project. Finally, you have to write the abstract. Once you have completed the paper, you have to write a summary of that work, that we found this result in about 250 words. It should not be very lengthy. Only the gist of the work is to be written in the abstract so that the reader can see whether it is of his abstract, whether of his interest. So abstract should be very brief and to the point, major findings to be given. Writing a research proposal. I hope if you are all teachers in a teaching organization, you know that if you write a project, you have to write the aims and objectives, where you have to make it very clear that what you want to do, the methods that you'll use, and especially the duration of the time, whether this project will be completed in 3 years or 5 years. You have to mention. Accordingly, you have to request for the financial from the organizations. A research proposal should always correspond to your expertise, because if you are doing something that is not relevant to your subject, then you have to take help of the other people, which may not be available every time according to your time and availability. It should be unique. That is something very common. Like, for example, one recipe should not match with the other recipe, but there should be a modification so that there should be something new. Results should be useful in developing the theories or the standard operating procedure. It should be so concise and so brief that it can be used flawlessly. And once it is used, it will become a standard operating procedure, and you will be referred to in every publication that this procedure has been taken from such and such author who has given it as a proof of his research work. So his standard work will always flourish and you can publish it without any hesitation. Here, finally, I give you a glimpse of a given laboratory where the chemicals are being used. And the arrangement of the chemicals is such that one should always remember that the liquids should always be kept on the ground, that is on the lower shelf. And solids should always be placed on the top so that if liquid drops from there, it does not damage. The solid, if falls there, the bottle breaks. It cannot damage the lab. So this is one of the instructions in the laboratory, that you should always have these facilities, and each corner should have a wash basin. You should not have wash basin away from the lab. And precautions should be taken that accidentally, if something happens, then you should have the first aid available in the laboratory in each corner. This is what I have shown you, and the last slide is about the main gate of the university that stands for its identification. This is the great mosque of the university. You can see one of the angles of the university from the back. That looks beautiful. And finally, I thank you for your patience. I hope that you would have learned something if you want to become a research guy in the laboratory or in an organization. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank
Thank you,
you.
sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you very much.
Dhanyavad, sir.
Thank you,
Thank you.
sir.
Dhanyavad, sir. Thank you so much. It was a nice
Thank you,
lecture,
sir.
sir.
Thank you very much,
Thank you,
sir.
sir.
Very much information
Thank
I
you,
got.
sir.
Was a
Thank
nice
you,
lecture,
sir.
sir.
Thank you so much, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
If you have any questions. Do you have any question? Okay, fine then. Thanks.
सर को गाइड बनने की क्या एलिजिबिलिटी रहती है सर?
जी?
को गाइड बनने के लिए इसके लिए भी एलिजिबिलिटी होती है सर?
वो गाइड के लिए एलिजिबिलिटी गाइड के लिए
सेम
वो गाइड के लिए एलिजिबिलिटी वही है जो गाइड के लिए एलिजिबिलिटी है।
ठीक सर।
आप को गाइड के लिए अगर सोच रहे हैं तो उसकी भी एलिजिबिलिटी वही है जो गाइड के लिए।
यस सर।
लेकिन सिर्फ उसमें ये जरूरत होती है कि आपके पास अगर वो फैसिलिटी नहीं है और को गाइड के पास है।
ब्रजेश सर ऑडियो म्यूट कर लीजिए ब्रजेश सर।
Yes, sir.
ऑडियो म्यूट।
आवाज आ रही है आपको? Are you getting my voice?
यस सर।
Yes,
sir.
आपको गाइड के लिए पूछ रहे हैं।
Yes, sir.
तो वो गाइड की
सर इस पीपीटी प्रेजेंटेशन
Yes,
का
sir.
पीडीएफ या जो डिटेल्स ये जो पीडीएफ शेयर हो जाएगी।
वो गाइड की क्वालिफिकेशन वही है जो गाइड की क्वालिफिकेशन है।
ठीक है सर, ठीक है, ओके सर।
लेकिन जब आप को गाइड किसी को रखना चाहते हैं तो इसलिए रखना चाहते हैं कि वो फैसिलिटी और वो अवेलेबिलिटी चीजों की उनके पास है जो आपके पास नहीं है, तो उससे लिए आप हेल्प लेते हैं।
ओके सर।
ठीक है, और कोई चीज पूछनी है तो बताएं। Okay, fine then. Thank you very much. I stop it here.
ओके सर, थैंक यू सर।
Thank you.
Okay, sir.
Thanks a lot, sir.
Thank you, sir.
Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you,
sir.
sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Sir, can you please share the PDF or PPT of this session?
You can request the director.
Okay, sir. Thank you, sir.
Okay.
मजर सर तो लीव हो गए हैं, लेफ्ट कर दिया उन्होंने। कैन वी आल्सो लीव?
हाँ, लीव हो सकती है मैडम आप।
अच्छा अच्छा अच्छा।